Welcome everyone to the guest speaker event. Today we have Vishal. Okay, can everyone hear me? Hear me well?
Loud and clear.
Oh, okay, cool. All right, so I am Scott Nguyen. I am the VP of Operations at UW Applied Analytics. I really appreciate everyone comes here today and be part of this event. And today we have Vishal Khatri. Vishal is currently an intern at Amazon as a data scientist. And Vishal used to work as a business intelligence engineer. So he transfers from that position into a data science. And today we are going to learn more about his journey, how he got into data science. And we also be able to learn more about the data science industry as well. So Vishal, if you are ready, you can start sharing your presentation slides, if that's okay.
Yep, sure. Thank you so much,
Sounds
Scott.
good. Yeah, thank you.
Let me know when you guys can see it.
Yep, that looks good. Yeah.
Okay. Okay. So I was going to start with a little introduction. I think Scott has already covered that. So I just wanted to know if you guys can hear me correctly. Am I audible to you guys?
It's good now, yeah.
Yeah, okay. So I just wanted to make sure that we have good time for questions. If you guys have, so I have kept a huge amount of time at the end for questions. So I'm not sure, Scott, how are we going to run about the questions? Are they going to type it in the chat, or they can just speak up, whoever has a question? I'm not sure how we are going to run the question and answer section.
Yeah, if anyone have the questions, you can give me a chat in the box, and then I'll put it in and ask Vishal after the presentation.
Perfect. Okay. So I'll just get started. I'll keep the presentation part really brief because I want to focus on the questions you guys have and what you guys want to know. Okay. So I was thinking what I should title about, this presentation. And then I thought everyone these days is thinking of for data science as, some magical thing where you input some data and you get predictions. Okay. But there is a lot that goes before and after that piece that is equally important. So I thought it'll be a good time to focus on that, because I think the magic / modeling part is something that you guys might already be aware of. So I wanted to highlight what are the important things that happen before and after that are equally important in the industry. Now, just moving forward, people that have this question, okay, how do I become a data scientist? Okay. Now the expectations are, okay, I'll learn about some fancy models, I'll apply them. I apply these difficult techniques to predict everything from, let's say, rainfall to hairfall. I'll pass around my Python notebooks or R files and I'll share my work. Not how it works in the industry. The reality is, if you want to become a data scientist, there's a huge set of skills that you really need to get through, and it has to be done in a certain sequence. And this is not a gold standard. This is my particular observation that I've gone through from my academic and professional experience. So the first thing I would say is basically learning about databases, because no matter what organization you go to, they'll definitely have some relational data with them. And no matter what data science project you take up, one of the sources of your data will be a relational database. Okay. And a lot of the times it's important, and it's also easier to do some of your data manipulation then and there in the database before extracting it for your data science work. So having to learn databases is something that is primary, and it introduces you to a lot of things about what is a data structure and what is the data granularity. How do you define those and how do you understand them? So those are things that are very key, and databases in SQL are something that people normally neglect, and they think it's not for people in data science, but no, it is equally important. Okay. So, and the second thing is, sticking to one data science friendly programming language. There are many out there at the moment. You can choose to be on Python, you can choose to be on R. There are many other languages that you can do your analysis in. It is good to try them out, but it is also a good idea to have that one language of your choice in which you want to progress. Because once you choose that language, you can build your skill set and focus your attention only on that language. And when it comes to the industry, and I speak for my team and the teams I've seen around in Amazon, there is no barrier to what language you use for your analysis. In my team, half of the team uses Python and half of the team uses R. Okay, and it's totally fine. No one is mandated to switch their server, and they want you to deliver in the language you're comfortable with. Choose one programming language and focus your. Now, the third thing is learning the basics of statistics. Now, data science might sound like a fancy term, but it all originates from statistics. You need to have that core background in statistics, just to interpret some of those coefficients that you see after you run your models, and what do they actually mean, and how do you interpret them? Okay, so a baseline of statistics is something that you would need, that is a very important skill set to become a data scientist. And apart from that, the one thing that people normally think is only a BI skill set, but is also a data scientist skill set, is having a data visualization tool under your belt. Now, when you get your models up and running, when you have your accuracy scores and a lot of things, the fancy things that you put up after you run your model, how do you communicate that to someone who doesn't know the D of data science? Now, if you tell them, okay, these are my p values and this is my feature importance, you've just thrown them out of context and in a place that they don't want to be. With data visualization and presenting your work in a meaningful and insightful way is something that is critical, and it's something that I'm currently working on. So I am currently working towards the data visualization piece for some COVID related analysis, wherein we are checking how is the safety at different Amazon warehouses that are delivering your packages even when COVID is around. So we are measuring the impact of COVID on the safety of these sites, because we want to make sure that our employees are safe. Okay. So now I think after you've done all these things and you have everything under your belt, then comes, leveraging that, the magical models that you have, and, the predictions and everything that you normally hear about. Okay. I think that's when it comes out. That's the stage where it comes in. And you might think that I'm going totally nuts here because I've put the models so low in, the journey of a data scientist. But I'll tell you why. Because this is the ideal data science process for any project that you take up. Okay. So this is a cycle. The first thing is, obtaining your data. Then it comes to, cleaning the data, having some initial exploration when it and looking at the patterns that you could see very easily. Then comes your modeling piece. And this entire cycle is incomplete without the interpretation where the data visualization piece comes in. Okay. So I thought what we'll do is I'll give you a run through of each and every step and probably tell you from my experience what are the skill sets that you would need to develop in order to, develop for each and every phase in this cycle. So let's just get to the first piece. So obtaining the data. Now, when you go away from academic projects to industry level projects in data science, I assure you that there'll be more than 4 sources of data for a minimum. Okay, there will not be one CSV file that will be uploaded by your professor that you can start working on, or one extract that you pull from somewhere and you start working on. There will be different types of data and from different sources. So the first thing is about understanding that data and what is the level of granularity. So just to give you an example, let's say you have a database which has employee level data, and then we currently are doing Reddit, Facebook, and Twitter polls to see if our employees have posted something for safety on these websites. Now, one employee can post multiple comments. So for one employee, I'll get like, so showing my internet connection is unstable. Can you hear me, Scott?
Yeah, it's good now. It's just got lagged out a little bit. So
yeah, so it was showing unstable, so I stopped there, and then I'll continue.
Yeah, now it's clear. Yeah.
Yeah. So I was just saying that, we have data from a relational database and we are pulling data from different sources like Facebook, Twitter, Reddit, data feeds. Now, for an employee in the database, there's just one record, but this is an employee. Now, for the same employee, I can have 10 tweets from Twitter, 2 posts from Facebook, and let's say 5 Reddit threads that he has started. Okay. And there comes, a different data source from a CSV file, which measures their attendance. So there is a data, there's a row for the employee for every day. Now, if I have to do some analysis at a site level, I need to aggregate all this data at the same level. So understanding the granularity in different sources is a very key thing, in your obtain the data phase. And then it's about how do you query and combine. For the relational databases, you really need to know how will you query and you export that data for your use. And then because these data sources are at different levels, how do you actually combine them into one source so that you don't have data repetition and you have the right data for your analysis? So that is a key step, that takes a lot of thought process and will always challenge you. Any industry project, you will always have more than 4 or 5 sources of data. You just cannot have one, because the problems keep evolving, and the way this data is structured, and it has been there for years. So you just can't say, okay, let's change all of this right now. Okay, so you have to follow that pattern, and then you have to make your data suitable for you. And the skills that are primarily required over here will be SQL, because a lot of the times you will have a relational data source. Definitely you will have a relational data source. So SQL is primary. And then comes a language of your choice, Python or R. I've just listed the 2 popular ones. You can choose any. Okay. So just giving you an example that, a programming language that can merge files or feeds from different web sources. So that's for the first step. Now comes the second step, which ensures that we don't have a garbage in, garbage out problem, which is the most common problem in data science. Now, if at the start you provide rubbish data, the predictions you make will be equally rubbish, as bluntly as you can say. And this is the most common problem with all, data science projects that happen in the industry and in academia also. So if you don't have the right data, you don't have the clean data at the start, your model is going to suffer. And even if it doesn't suffer, and if you see prediction or accuracy scores, of 90%, there's a very good possibility that the quality of your predictions is not that good. Okay. So this is a step that ensures that we don't run into that problem. And the more time you spend on this step, the better your model will be. And this normally involves, you might already know this, and this is, you merge all your data sets, you split them according to your need, replacing NA values. These are the most common tasks. So basically cleaning your data. Let's say one of the things that we are doing currently in our project is when we have Twitter data, we fetch in through a keyword. So we get both tweets and retweets. Now, the one thing that we don't want to do is not give too much weightage to a particular data point. So we don't want to count the retweets. Okay. So we just want the original tweet to appear. Okay. And in the original tweet as well, we just want to remove punctuations. We just want to, get our nouns, our pronouns, and everything. What's the tone of the tweet? Okay. So having that data cleaning, and if there are any links, we just want to remove those links. Okay. If they've referenced a video, we just want to remove those references in the tweet. So those are things that will happen. And, if I collect, let's say 1 million tweets, it'll be like you have to do this for the entire data set. And there could be so many variations in how people tweet, because you have no control. There's no structure to Twitter or any other social media platform or any kind of data that you might be receiving from different web APIs. So you can not expect what data is coming your way. And that's where the cleaning becomes more important. I can say you will get to know new cases on how the data can be corrupted every time you take up a project. And you're like, oh, this is something that I didn't think about. So this is something also that I have to handle. And it's an iterative process. You just can't clean that data at once in the first step. It is an iterative process and you have to keep improving. So, and fun fact, this takes close to or more than 80% of the time in a project. This is the most major heavy lifting that you will do, because this will require a lot of thought process, a lot of exploration, a lot of what you call custom code for every project. If you have to apply a linear regression model in 3 projects, like I code in Python, so my references might be a little Python oriented, but if you import a package and you do a linear regression code, it will be the same line in all 3 projects, but your data cleaning will differ because you have to see what your data exactly is and what are the problems you can run into. So for this particular step as well, the same skills required, that is SQL and Python, or SQL and R, whatever your language of choice is, because a lot of the times it is good to get your data splitted, at least, if not do any replacing at the query level in relational sources, so that you're not pulling in unnecessary rows when you are going to merge with other data sources. So the first 2 steps is where SQL also is a very primary skill. So this is one thing that I'm reiterating again, that people think that SQL is not something that's required for a data scientist. We only work on Python. That's a misconception. The very foundation of your data science process in the first 2 steps, they depend on SQL, and they will always depend on SQL. So this was the point that I wanted to clarify. So now let's go on to the 3rd step. And this is basically exploration. Now, when we talk about exploration, this is basically, just getting started. So you've cleaned the data and it is, let's say, 1 million, 10 million rows. How do you know, what your data looks like? You can't just go through 10 million rows and let's say 20 odd columns, okay, in your data. So that's like 200 million data points. You can't go through each and every one of them and, manually look through, okay? So that's where, descriptive statistics come through, okay? And you have to analyze what are the data points you have, okay? These are the 20 things that I have, okay? What's the spread of the data? If I have a age variable, okay, what is the age range in my entire data set? Am I only looking at an age range of 20 to 40, or am I looking at 20 to 80 years of people? So it could be a very huge difference, and it will impact an analysis, okay? And you look at what are the quantitative and qualitative features for you. So you guys already will know, anything numeric, quantitative, anything that's descriptive is qualitative. You see, and how do you actually handle your qualitative variables, okay, for your predictions. So this is also where data visualization comes in very handy, because if you have something at the range of 10 million, you just can't show a table to anyone. They'll scroll, and they'll be like, okay, let's grab this project. We don't want to look through so much data. And that's where data visualization comes in. And then you can show, okay, we have 10 million rows, but see, this is how, our data is distributed. And these are the minimum and maximum values. And this is the range for our, let's say, if it's a pricing data source. So this is the range of our prices, okay? These are the kind of different values that, let's say there's a status. So this is the different values a status can take, okay? So this is the way you actually narrow down the data and you look at what's actually in the data to give you a better idea of what really is coming your way. From the 10 million rows, there might just be 5 unique values. So that's when okay, so this can be split into 5 groups. So the next step you take is to see if all those 5 groups have equal representation. And then going forward, every project has a different process, but these are the things that will remain constant, exploring your data at the start. So for the skills required, it's again, a programming language. And I've just listed some of the packages that I have used before in the languages that I have experimented with. So Python, you just have your basics with NumPy, Pandas, Matplotlib, and to some extent, scikit-learn. And you have R, you will have dplyr and ggplot2 for your SQL related things and your visualizations. And you just need to have, a knack for data visualization. What is the kind of graph I should choose for this particular variable? If I'm showing, a relationship between 2 variables, what is the graph that I choose? If I'm showing the spread of data in one variable, what is the graph that I should choose, which will best convey the message? And now is the time when comes your knowledge of statistics, because now is the time when you will be looking at, is there any correlation between the columns that you have, okay, with your target variable? And is there any, so you'll be plotting some of the graphs and seeing, okay, is there a trend that you can see? Like, is there something obvious that you can point out right away at the start, because it will help you in selecting and building your model going forward. Okay. So these are the 3 steps which take up, let's say, 60% of the process, because we have 5 steps. So these are the first 3 steps. And this is, I would say, close to 85% of the time or more in any data science project. And after this has happened, then comes the step that I think all of you like. It's called the model step, but I think a lot of people refer to it as the magic step, because something magical happens in those models and predictions come out. So I have labeled it that for you. And then the first thing that I have here is very important. The effectiveness of the model that you build, it is highly dependent on your previous steps. The first point that I have in this step is the way you do your first 3 steps and how accurately you do them will define how good your model becomes in this particular step. Okay. And before this, there's no consideration of the model. Okay. You don't think about whether you're going to apply a linear regression, logistic regression, what kind of model you're going to apply. Are you going to go for a random forest? Anything. Okay. All those fancy words come here right now. And before this, you don't think about them. You have to get your data cleaned. You have to get your data merged well. And that's why this is a step where you focus on what will be your model or algorithm that best suits your problem statement, and what will be, the core set of features that you feel, will help you in driving your predictions. Now, this also piggybacks on the third step, where, you've seen correlations between different features and your correlations between those variables and the target variable. So this is where your third step helps again. Okay. And, you spend a lot of your time in selecting what will be the right algorithm, or even, and what will be the different features. And you apply different techniques to see, okay, what is that, good set of features to apply, because a lot of the times features have dependence among themselves. Okay. And, you don't want those features to like double count in your model predictions. So if there are 2 variables that are correlated among themselves, an increase in one will definitely lead to an increase in the second one, and then your predictions go off. So, there are different things that you have to take care of while selecting your features and your model in this step. And the skills required for this one, along with the things that you've been requiring before, is, a knowledge of the machine learning algorithms, be it supervised or unsupervised. And then, the libraries in different programming languages that, support machine learning algorithms. Okay, scikit-learn for Python. Okay, that, you have your different models available that you can import. And if you look at, I know a lot of you would have done, data science programming before. If you look at your modeling code where you, apply a model, it's normally a 3, 4, 5, 6 sentence statement code. But your cleaning and everything takes up a lot of time, a lot of lines of code and a lot of time as well. So that's why I mentioned at the start that the cleaning bit will differ in all projects, whereas implementing a linear regression model will be the same lines of code with different inputs in all projects. Okay. And when people think that, yes, this is the most toughest part, the toughest part comes after this, because you've already solved a problem, but your solution doesn't matter if you cannot convey what it does. Okay. Now that this is one of the most important parts that I've learned in my recent internship is you have to think backwards from a customer's standpoint. If you have a model, if you have implemented, a data science solution to a problem, think how your customer wants the solution. Okay. Think backwards. Let's say, if you've taken up a project with a housing data set to predict house, what should be the housing prices. Okay. Think backwards from a customer, or someone who is trying to rent out a house. Okay. What will they look at? They'll see, okay, what should be the price that I should, be putting on my house, depending on my neighborhood. Let's say that's one thing. So when you show your results, you don't say, okay, neighborhood is correlated with a p-value of this. That person doesn't know. Okay. He will not be able to comprehend what you mean. Okay. And then that's where, you build, a visualization or, a presentation or anything, that's more easier, wherein they can select a neighborhood and they can see what is the average price. Okay. Depending on what your model outputs. Okay. And if they enter some more features, let's say if it's a housing rental and if they enter that their rental has 3 bedrooms, 2 bathrooms, okay, and it's in this particular locality, then this is what your model predicts. Okay. What if they want to see if they should increase their prices during summer, because a lot of people travel during summer. Okay. So yes, on the visualization, there should be a way to input months also. Okay. So this is how you think backwards from your customer, that if I'm presenting this data, I just can't tell someone, okay, this is your predicted value. There has to be a user experience involved along with it, wherein you tell them, okay, this is how you consume the model. Okay. So visualizations, that present actionable insights and with a easy navigation. That's why I've stressed on that. Will help the users a lot. And that's where, all your accuracy scores, all your predictions will actually be fruitful to someone, and they'll be able to use it. And they'll actually switch from being just numbers in your Python notebook to something tangible for solving a business problem. Okay. And that's why the skill set required for this step is, really wide, and something you might not expect that a data scientist needs. For some of the people, at least, they don't expect that. Yes, you do need visualization tools that we've mentioned, but you need PowerPoint, to convey a story. You need storytelling abilities. You have to build a story around, the business problem you're solving and how your model solves it. Okay. And you need the domain knowledge, because if you are working with a housing data set, you should also have that domain knowledge that, okay, what will people be thinking, that what are the big features of their house, and are those the features that we can incorporate in the model? Like I mentioned, let's say bedrooms or locality, time of the year. This is what a user will think like, someone who's renting. So having that domain knowledge about, what domain you're working in. And this comes with experience. Once you start working in a particular domain, you move ahead with that. That's when you actually get into the nitty-gritties of how much domain knowledge you can apply. Okay. So this is how the process works. Okay. On a data science project in the industry. Now, I know that this might be something that you guys already knew, but I just wanted to go through this to, stress the fact that if you think building models is what a data scientist does, then that is a big myth. And that's the myth I wanted to, I would say, shatter a little bit. And that's what I spoke to Scott also about, that, this is one thing that I really want to tell people, because I switched from a BI to a data science position now. And I'm still in transition, because the duties that I've received as an intern are mostly BI related. And they are mainly involved on the first 2 steps, I would say, and the interpretation step. Okay. And when I transition to a full-time role, I'll be given more on the modeling piece and more on the descriptive analytics piece. And that will happen slowly, because one common thing that's in the industry is the core data science or research science positions are normally held by people who have a postgraduate, PhDs. Okay. So getting into, a core data science role with all the responsibilities, there are multiple options. You maybe have an internship and that converts, or, start with maybe a BI. You should not be afraid of starting with a BI, because a BI does everything in the 1, 2, and 5th step. Okay. And these are equally important, like I mentioned. And I would tell you a statistic from my team. My team is a 16-member team, and 8 of the research scientists on my team are BI converts. They were BIs, and then they got converted to research scientists, because they did their BI work and they just asked for an opportunity. They were given the work, they proved themselves, and the title was changed. So I would say, don't run behind those titles, run behind data related work. And my personal 2 cents would be, getting into a data analyst / BI role would be the perfect choice for anyone who's just graduating from college, because you get to work at the granular level of data. And that's when you can build your perfect transition to data science. So that's all I had, because I told you, Scott, I'll keep it brief. I'll have time for people's questions. So I finished at 6:30. I have half the session for questions, and if people don't have questions, they can enjoy their evening.
Yeah, thank you so much for the presentation. I think that it was very helpful. And I actually like received a lot of questions from the audience, like because of like the people are
Okay,
curious about your like backgrounds and experience. So yeah, I'm gonna go through each question. I'll try to go through as many as I can.
perfect.
So yeah, so the first question is from Johnny. So
Okay.
he's asked that by learning databases, do you think SQL is the best like language to
Yes,
start off?
yes. So the thing with databases is SQL is the standard. You can have different database providers like Oracle, SQL Server, and there are many Postgres. There are many in the market. The only thing that's different is some of the functions that they implement. The core remains SQL. So SQL is your gold standard
Right.
for databases.
Oh, I see. Yeah. So yeah. Yeah, and then I'm gonna go to the second question
Yeah, yeah, yeah.
from Angel. Uh, so she asked that like, does your major matter when it comes to data science if you are an undergrad, or if you have skill, like would that be like a factor more than like a major? So
Yes. So I will tell you that's a major factor because I'll tell you I'm working closely with this one person. I won't reveal his name, and he's the NLP expert of the team, a team of 16 data scientists and research scientists, and he has a graduate degree in psychology.
uh, I
And
see.
we also have economists who work on data science projects. We have people from all different backgrounds. There is someone who's come from an industrial engineering background, but they have their data skills on point. So I think sometimes your major gets you into the door for an interview, but if you can show on your resume that you have the skills, I think it shouldn't matter.
Oh, I see. Yeah.
Yeah.
So, what would be the advice you have for like those who are not in currently in engineering major, um, to like what skill sets they should focus their time on to develop so that their chance to get into data science would increase?
Okay.
Do you have any advice on that?
Yeah. So people who are in a non, CSC major, I would say, people who haven't had a chance to explore the things that I just mentioned, my advice for them would be to start off with SQL. Okay, because SQL, like I mentioned, is at the core of anything data. Okay, and then SQL helps you and opens your avenues for different kinds of roles, be it a business analyst, BI, data analyst, and data science as well. Okay, so a good path for them would be to join as a business analyst or a data analyst, wherein they can get to work with some industry level databases, okay, and the data that's there. And on the side, if they can still start working on their Python or R, I would suggest Python very strongly. On their Python skills, they can make that transition internally, because all organizations, encourage that. For people who have the core data knowledge, they go on to take on research positions because they already know the data, and they are in a better position to know what the data is and how it comes in. So they become an all-round resource.
Oh, I see. Yeah. So, so you advise people to like to work on their as SQL skills firstly, and
Yeah,
to work on
Python.
like focus on Python
Yeah.
as your main language. Yeah. Yeah. Thank you for that. And also, I have another question on your project.
Yeah.
So, you can you tell us a little bit more about the project that you're currently working on? I heard you mention that you work on like the impact of COVID on like,
Yeah.
yes. So could you elaborate more on that?
So I am actually bound by an NDA, so I cannot reveal a lot of details. But I can tell you the problem statement that we're trying to, tackle, and it's a very unique data science problem. I would say that I don't think anyone in the industry has tackled at the moment. So what we are trying to do that because of COVID, and we are first trying to see if we have the right safety measures at our warehouses where our workers are still working, like I mentioned, to deliver the packages that all of you are ordering. Okay. So we want to make sure that are there any sites, we want to predict, are there any sites that because of lack of safety, we can see a strike or a walkout. Okay. We're trying to predict that given the factors that we have from the safety comments that we get, the safety questions we ask, and depending on a lot of different other media sources, can we predict something about what do you call them, if there can be a walkout or something at a site?
Oh, I see. Yeah, that's very helpful. And also like, um, for do you think that for people in non-engineering background, like to start off as like to get into data science industry, would doing more projects like related, would that be something helpful for them to increase their chance to become a data
Yeah.
scientist?
So that is the thing that will compensate for people having for them not having an engineering degree. So like I mentioned, it's about getting a foot in the door for an interview, for getting a data science role. People with engineering majors, and especially CSC or like info, they normally get that thing because the degree is related to data science. Okay. For people who are in
Right.
different majors, they can compensate that by having data science projects on their resume and structuring their resume in a way that their projects come up first before their majors show up, so that their work is at the top, and then people can see, oh, they've done data science work, so yes, we should give them a shot. So doing that, those projects will compensate for the major and help them get their foot in the door for an interview.
I see. Yeah, yeah, that's pretty helpful. Yeah, and another question from Kayla. Kayla asked, what data visualization software do you prefer to use the most in your work?
So that's the thing. So with data visualization, I would suggest that you probably try to use any one that you have readily available, because the choice of the data visualization software will differ from organization to organization, even project to project. So I was working on Tableau before, okay, from my previous experience, okay. And when I moved to Amazon, we have our internal tool that Amazon has built that's hosted on AWS. And because it is cost free, it's like free for us because it's internal, and Tableau comes with a license cost of, I don't know, $1,000 to $2,000 per person, and then you need an infrastructure to deploy it. I was told that, okay, we know you have data visualization skills, build this on our tool. So I had to literally learn a tool in 3 days. Now that's the thing with data visualization, you need to know what are the concepts behind data visualization. Like I mentioned at the start, if I'm showing a comparison between two variables, what will be a good graph type? Because all data visualizations will have the similar graph type. If I'm showing trend day over day, a line chart is the perfect option. Okay, so every data visualization software will have a line chart. So I would say start using any one, but just get your visualization concepts clear. So how do I highlight? Even color is a very important part. If something's going up, show it by green. Something's going down, show it by red. Okay. And how do you put on filters so that users can interact? Okay. So get those data visualization skills and not really, stick to a tool. You can just stick to anyone, because you might need to change that given, if you have to use something by your company standards. So just stick to one. I would say Tableau is a very good choice. UW gives a free license for 6 months or a year, I would say. So you can start with that.
Yeah, I agree. And also, like, just a follow-up question. Do you think, like, so you mentioned there are like steps in what the data scientists do, cleaning and finally and analyzing with models and then presenting the data.
Yeah.
I know that besides like the last step, you use a lot of visualization, but do you use like data visualization at all when you try to in the previous processes in like cleaning the data and applying the models?
So in the third in the third step, it becomes critical. Once you clean your data, in the third step, when it's about analyzing your data and just looking for simple correlations or looking for what's the spread of your data. That's where some of the visualizations come in, especially scatter plots and I would say histograms. So when you look at what is the range of your data and how let's say a couple of variables are correlated. So those are times when you can actually do some visualizations. Ideally, you will not export them to a data visualization software. You will probably do it in Python or R because they have those packages available, and you need it only for that step. The major chunk of the data visualization with a tool comes in at the fifth step. But yes, the skill set of data visualization is needed on the third step as well.
Oh, I see. I see.
Yeah.
Yeah. And then also, like, I'm curious, what really triggers your, why do you change for your career path from like a BIE to a data scientist? Is there any like reason you want to change that, transfer that career?
Not really. So I did BIE for about 4 years back before starting my graduate degree. And I was mainly doing operational reporting at that time. And I wanted to really give analytical reporting a shot. And I really wanted to, my growth was a little stagnant in my role. So I thought that would be a good time to do a master's and see what's going on in the data field. And I really got introduced to data science after I, stepped foot in UW. So it was something new, and it looked like a logical extension to what I was already doing. I thought that I at least had some skills to pull off the first few steps, so might as well learn the entire process. So it felt like a logical continuation. So that's probably the reason why I took it.
Yeah. Yeah. Thank you. Thank you for that. We just try to learn more about your backgrounds and stuff.
Yeah.
Yeah. Also, another question from Kayla. So we want to know, do you have any recommendation on the sources, like websites that we can enhance our Python or SQL or and then R skills?
Yeah, I was hoping this would come up because I do have. What I can do is I can consolidate those and send it across to you in an email, and you can pass it along. So I'll tell you verbally,
Yes.
but what I'll do is I'll also send it across. So for people who are starting with SQL, there is a fantastic playlist on YouTube with about 140 videos, but they're very short. Okay, and if you know some concepts, you can just skip through. They tell you in the title what they're going to teach. So that's a really good resource. Okay, and for SQL, then when it comes to visualization, now is the perfect time to learn Tableau because Tableau is offering a 90-day free subscription because of COVID, because they want people to learn. And you can take up one of their paths. They have different paths, like where do you want to become a Tableau analyst, a Tableau data scientist? Okay, what is your role? And if you don't know, they have a quiz to judge what will be the best path for you. Okay, and then that is something that you can really use. Okay, and it'll be the perfect time because they're offering it for free. Normally these what do you call, paths are paid. So that'll be good for Tableau. When it comes to what else is there? There's SQL, there's Tableau. Anything else that Python? Yeah, Python. For Python, yeah. So for Python, I would say courses available. I'll have to look through those. I can send across those emails in the email to you, and yeah, and I can send a few more links across. So these are very common sources, but I would say if someone wants to learn data visualization, now is the right time to learn Tableau because they're offering it for free.
Oh, I see. Yeah. Yeah, like you can send me the link and then I'll.
Yeah, you can forward it across to everyone. Yeah.
Yeah, I follow up with like the members. Yeah. Also, I have another question from Nick. Okay. So how many years you think like is average from becoming like from an analyst position to a data science position, like the experience years?
I would say there's no fixed timeline to it. It all depends on the kind of projects you get. okay, and the kind of scope you have for diversification in your role. So if you're working in a research team, let's say as a data scientist, data analyst also, and you just work with the data piece of it on a SQL level, or you work as a BI only for visualizations. But if there is scope and work in your team or organization for a data science role, you can just chip into that work in 6 months also, or if you feel in a year. Okay, and when you start, contributing a little and learning from your peers, you can then transition in the next 6 months or a year. So it can happen from anywhere between, let's say, a year to 2 years, if you have the right opportunity and the right project. But it depends a lot on that. Or the other way is, you keep doing some projects on your own and look for a role that more aligns, with your needs. That again, I would say, is very personal, that timeline of depending on how many hours you put in, and the kind of resources you're using. So that again is very variable depending on person to person.
Yeah, thank you. I have a question on my own. So
Yeah.
So what you think, like in big tech firms like Microsoft or Amazon, what do you think like the data science industry will head in the next let's say 5 to 10 years?
I'm sorry, you cut off in between. Can you please repeat? Hello, Scott.
Hi.
Yeah, you cut off in between. Can you please repeat the question?
Oh yeah. So we're in like big tech firms like Microsoft or Amazon. Where do you think like the data science industry will be in the next like 5 years or 5 to 10 years?
I would say there'll still be, I don't know, the kind of problem statements that they'll be looking at will be very different and very huge, but I'm sure that the process will still remain the same. Okay, so if you want to become a data scientist now or 5 years down the line, I think the process remains the same. So you still have to focus on those 5 steps. The only piece that will keep evolving is the kind of models that you can apply. Okay, and that's iterative learning that you do over a period of time as and when you go on. So I feel the kind of projects they take up, the scale will increase, but the process remains the same.
Oh, I see. So it's pretty much like it's gonna increase at like consistent rate, right?
Yes, the scale is going to increase at a consistent rate. As and when we have those small successes for projects, we are going to expect more and more from data science.
I see. Yeah. See if I have any questions. I think those are all like the questions that I've got from the audience. So I think like thank you so much for coming here today. I think that your presentation was very helpful.
Thank you so
and
much.
we learned a lot from it. So like also, what do you see yourself like in I don't know, like in the future? Do you see yourself be a data scientist in the next 5 years, or what's your like future career goal look like?
I would say I just probably look towards what's the next data problem that I want to work on. I don't look too far into the future because things change very rapidly in the industry. So I just focus on the next data problem that I'm working on. So right now, like I mentioned, I'm working on predicting those sites with risk. That's all I'm looking at from a data science perspective right now, because things will change rapidly in the industry. So I just don't want to be fixated on the idea of something and then not be able to adapt to the changes that come in.
Oh, I see. Yeah, that's great. Yeah. Thank you, Vishal, for being here today. And thank you everyone for tuning in today to join this presentation. So I will send you like the links that Vishal was going to present to you in class with like a follow-up email. And thank you so much for being here, Vishal.
Yeah, thank you so much, Scott. Thanks for the invitation.
Thank you, Vishal.
Yeah.
Thank you, guys. Stay safe. Bye-bye.
Yeah, thank you.
Bye. That was an awesome presentation.
Yeah, I know. Yeah, very, very helpful. Very detailed.
Way to MC it.
Oh yeah. I'll follow up with him to have the presentation uploaded to the website if that's what you want.
Yeah, that sounds perfect. We can just we can drop a link in the Facebook chat, and then also in next week's newsletter we can attach those at the bottom.
Sounds good. Sounds good. Yeah.
Thanks. Also, since this is recorded, we can upload that to YouTube, and we'll have the links in the description there too.
Oh yeah, that's true. That's true. Yeah. And everyone, if you also like, if you wanna add Vishal on LinkedIn, you can feel free to do that. It's a good way to get referral when you apply for jobs. And I'll send you guys like his LinkedIn right now, so you can take a look at it. All right. So.